In this video, we'll learn how to factor a difference of squares. A difference of squares is a polynomial of the form a squared minus b squared, where a and b are monomials. A difference of squares of the form a squared minus b squared factors as a plus b times a minus b. To check that this factorization is correct, all we have to do is multiply out a plus b times a minus b and see that we get back our original polynomial a squared minus b squared. Now to multiply something like this out, I need to use the FOIL method. F stands for first, so we multiply the first terms a and a to get a squared. O stands for outer, so we multiply the outer terms a and negative b, so this gives me a negative a times b. I stands for inner, and the inner terms here are b and a, which we can write as ab. And L stands for last. The last terms here are b and negative b, so their product is negative b squared. Now if I simplify this, we notice that we have a minus ab here and a plus ab here, so those will cancel out, leaving me with just a squared minus b squared. So we see here that a plus b times a minus b is equal to a squared minus b squared, which tells us that we have the correct factorization. Let's work through a few examples. In our first example, we want to factor the polynomial x squared minus 16. This is a difference of squares because we can write this as x squared minus 4 squared. We have the difference of two squares. So in the difference of squares factorization, we start off with a squared minus b squared. In our problem, the a is the x and the b is the 4. This factors as a plus b times a minus b. So here, this is going to be x plus 4 times x minus 4. If we wanted to, we can check that this is correct by multiplying out x plus 4 times x minus 4. So again, I can multiply this out using the FOIL method. The product of my first terms, x and x, is x squared. The outer terms are x and negative 4, so their product is negative 4x. The inner terms are 4 and x, so their product is positive 4x. And then our last terms, 4 and negative 4, gives me negative 16. Again, the negative 4x and the positive 4x will cancel out, leaving me with x squared minus 16, which is our original polynomial. So we see that this factorization is correct. In our next example here, we want to factor 25x squared minus 9. Again, this is a difference of squares, but it might be less obvious. The first term here, 25x squared, can be written as some monomial squared. We can write it as 5x squared, because if you take 5x and multiply it with itself, we do get 25x squared. Then we have minus 9, which we can think of as 3 squared. So if we think about this difference of squares in the form a squared minus b squared, our 5x here is our a, and the 3 is our b. This polynomial factors as a plus b times a minus b. So in our case, we have 5x plus 3 times 5x minus 3. So that's how we factor 25x squared minus 9. In our next example, we want to factor 4x to the 6th minus 49y squared. Again, we'll want to think about this as a difference of squares. We want to write it as some monomial squared minus some other monomial squared. So looking at the first term, 4x to the 6th, can we think about this as some monomial times itself? Well, 4x to the 6th can be thought of as 2x cubed times itself. So I can write it as 2x cubed squared. Then we have minus 49y squared. Can we think about 49y squared as some monomial times itself? And again, we can think about this as 7y times itself. So I'll write this as 7y squared. So in this example, our a is 2x cubed and our b is 7y. Once we've identified our a and b, we can write down our factorization as a plus b times a minus b. So that's going to be 2x cubed plus 7y times 2x cubed minus 7y. So that's how we factor 4x to the 6th minus 49y squared. The last example we'll look at is 3x cubed minus 12x. Looking at these terms, it does not seem like we have a difference of squares. 3x cubed is not a square, and 12x is not a square either. But there's something that we can do. Whenever you're trying to factor a polynomial, a good first step is to look at each of the terms and determine if there are any common factors. Well, if we look at the first term, 3x cubed, I have a 3 and then 3 factors of x. In 12x, I can rewrite that as 3 times 4 times x. We see here that we have some factors in common. We have a 3 and an x in both of our terms. So our first step will be to factor that 3x. Using the distributive property, we'll pull out the 3x. So I'm going to have 3x times whatever's left. In our first term, we have x squared left, and in our second term, we have minus 4 left. Looking at x squared minus 4, you might notice that this is a difference of squares. We can write this as 3x times x squared minus 2 squared. So if we want to think about x squared minus 4 in the form a squared minus b squared, our a is x and our b is 2. So let's factor this now. We have 3x still out in front. Then x squared minus 2 squared will be factored as a plus b times a minus b. So that's going to be x plus 2 times x minus 2. So 3x cubed minus 12x factors as 3x times x plus 2 times x minus 2. So that's it for this video. In our next video, we'll talk about rational expressions.